All right, welcome back everyone. Today I'm looking at question 10. This is a pretty complicated question. And if you were to do it like the traditional way of using algebra, it would take you a long time. So I'm going to show you a different method to solve this one. Okay. So a campaign researcher would like to estimate the proportion of registered voters that will vote for his candidate. He runs a poll each week asking registered voters their candidate preference and calculates a 95% confidence interval to estimate the true proportion of registered voters that will vote for his candidate. On week 39, his confidence interval was 0.52 to 0.56. And on week 40, which is the last week of the campaign, he wants to conduct one final poll. He would like his 95% confidence interval to have a margin of error of 0.01. Use the previous week's information to determine the minimum sample size needed to achieve the researcher's goals for estimation. Okay. So let's see, the first thing here is, okay, week 39. Let's look at the interval. So visually speaking, the interval has the two endpoints and it has some estimate in the center. Okay. The endpoints are 52% and 56%. So just doing mental math, you know that the midpoint, the center, is going to be 0.54. Okay. And that center, that is the sample proportion. That was the estimate he got from his week 39 poll. Okay, so we're going to label that p hat. Okay, and that's the value, that's the information we're going to use from week 39 to now figure out how he's going to get a margin of error of 0.01 in week 40. Okay, so let's take a look at week 40 now. And this is obviously a confidence interval about a proportion. So let's start with that formula, p hat plus or minus z-score times square root p hat 1 minus p hat over n. And we want to have a margin of error of 1%, 0.01. Okay. So the other thing we know is that it's a 95% confidence interval. Okay, and so that's the hint as to what z-score to use. You can look it up in like table A or table B, but this is one that you should probably know by heart. It's 1.96. Okay. All right. So the piece there that I circled, right, that piece of the formula is the margin of error. Okay. And so we know what z-score to plug in. We know what value to plug in for p hat. And our choices there on the left, right, these are all the different values that we're going to test out for n. So we're really just going to use guess and check here. Okay. And we're going to keep guessing and checking until we calculate a value, a margin of error here, that's as close to 1% without going over. Okay, so it's close to 0.01. Okay, so let me pull up my calculator here, and I'm going to turn it on, and let's do 1.9. Oops, sorry. Let's try that again. 1.96 times the square root of 0.54. Now 1 minus that is going to be 0.46. And let's test out choice A. So choice A says sample size 96. Okay, so that produces a margin of error of 0.09, 9%. And we want a margin of error of 1%. Okay, so A is not the correct answer. Okay, so let's test out the next value, 9604. Okay, so here's a neat trick on the calculator. If you press second enter, it'll pull up the last thing you typed in, and then you can go back and just make little changes to it. So now I'm just going to change the sample size to 9604. And you can see there that that produces a margin of error of 0.009967, which if you were to round that to 2 decimal places, it would be 0.01. Okay. So when I was first doing this problem, I was about to stop right there because I thought, well, if I rounded that to 2 decimal places, it would give me a margin of error of 0.01. Until I realized, like, oh, C and D are also very similar in size to B, and it might produce a margin of error that's even closer. Okay, so I'm not going to throw out B yet. I want to take a look at C, D, and C and E as well as D. Okay, so the sample size in B, 9604, got us pretty darn close to a margin of error of 0.01. But let's see if we can do one better. Okay, so now let's test out choice C, which is a 9543. Okay, and look at that. Okay, when I use that sample size, the margin of error is 0.009999. Okay, which is almost as close as you can get to 1%, 0.01, right? So C is a better choice than B. Okay, all right. Let's test out D just for the sake of it. Okay, using my little shortcut, second enter, and let's type in 11,187, and you get 0.00923. So that's not as close. That doesn't get us as close to the desired margin of error of 0.01. And so still C is looking like the best choice so far, but we've got to test out E. Okay, E might get us a little bit closer. Okay, so 9589. Let's see, 0.0099757. Okay, so that got us close, but not as close as C, right? Let's see if I can pull it up here. 9589, not that one. 11187, not that one. Okay, here was C, 9543. Okay, that got us the closest to the desired margin of error of 0.01. So there you have it. You can use guess and check. It's going to take a bit of time because there's going to be 5 values that you have to test. But this is actually, I think, a lot better way of solving this problem than just trying to solve it algebraically. Because there's a lot of like little mistakes that can go wrong when you're trying to solve a complex algebraic equation. All right, thanks again for watching. See you in the next one.